Good afternoon, good evening, everyone, and welcome to this lecture. This is lecture number 3 in relative motion, and we were discussing relative motion in 2 dimension. And in the last class, we had discussed some very important points. We had seen what is the condition of two projectiles or two moving particles to meet. Their relative velocity should be along the same line. Do we remember this? Yes or no, everyone? Remember that part where we had seen two particles to collide, their velocities must be along the line joining the two particles. The relative velocity must be along the line. Now let us move ahead into the next thing and let us move ahead into finding out the relative velocities. So without saying anything, let me just give you this question, and this question will solve any doubt that we have in our mind to find out the relative velocity of one body with respect to the other body. This is a very common question that I have seen in many places in many exams. This just checks whether we understand the concept of relative velocity, and the question is like this: an old man and a boy. You can see here, this is a boy and this is the old man. Does not look old, it looks like a detective. Anyways, an old man and a boy are walking towards each other and a bird is flying. You can see the bird here is flying as shown in the figure. You just find out simple things. Find the velocity of tree, bird and old man with respect to the boy. Tree, bird and boy as by the old man. If you get one of these, don't have to solve all the three. This is just to get you to the case where you understand how do you find out the relative velocity in 2 dimensions. So instead of giving you the velocities in vector form, they have given you a diagram, and with this diagram you have to find out what is the velocity of all the three things. There are 4 things here: bird, man, boy and the tree. So you have to find out the velocities of all the three, the other three with respect to the fourth one. You do any of these questions, that will give you an hint to solving the other question. So solve any one of these. Let us try and solve question number 1. Find the velocity of tree, bird and old man as seen by the boy. So this boy becomes our reference frame. We have to find out the velocities of all the three other quantities, three other entities in terms of the as seen by the boy. I'll give you 2 minutes. You don't have to draw the diagram, you just have to see what are the velocities and then solve the question. Okay. The other class has just joined us, so we are starting off with today's question. A simple question is here. We have to find out the velocities of tree, bird and old man with respect to boy. There are 4 things that you see here. So let us see if you can do that. I'll give you 2 minutes to solve this question and tell me the answer. Everyone can see the question. It's a very simple question to start off the proceedings for today. And I hope all of you would be able to do this. Let me know once you are done. So I think all of you would have tried this. Shall I solve it for you? Yes or no? The only thing that we have to do correctly is just write all the velocities in the correct form. And here we will use the vector thing. You can understand that a unit vector along x-axis is I and the unit vector along y-axis is j. You can just write the velocities of all these people. Let us say velocity of the boy. B stands for boy. Velocity of boy, he is moving 16 kilometers per second like this. So it becomes 16I. Everyone understands this? Yes or no? Then let us say the velocity of the old man. M standing for man. He is moving 2 meters per second like this. So it will be minus 2I. Let us write the velocity of tree. Whatever we are writing are with respect to ground. I hope everyone understands this. Velocity of tree is 0 because the tree with respect to ground is not moving. Velocity of bird, if I write B, it will confuse. So let me write it as E. Let me call that bird as eagle. So velocity of the eagle is 20 meters per second at an angle of 37. So they have already resolved it for us. This is 16 and this is 12. So I can straight away write it as 16I plus 12J. Everyone understands this? Yes or no? Now what we have to find out is the velocity of tree, bird and man with respect to boy. Let me do it step by step here. So we have to find the velocity of tree with respect to boy. That will be the velocity of tree, which is 0, minus velocity of boy, which is 16I. So the answer would be minus 16I. Everyone got this? Boys? In the class? Other class? Only one boy at the last. No one else got this answer. Okay. ठीक है. Now let us find the velocity of bird. Bird I am calling it as E. E with respect to boy, that will be the velocity of E minus velocity of boy. What is the velocity of the bird? The velocity of the bird or E is 16I plus 12J. So 16I plus 12J minus velocity of boy. Velocity of boy is 16I. So you have the answer as 12J. This is the velocity of the bird E with respect to the boy. The last thing is velocity of the old man. Velocity of man with respect to boy. So that will be velocity of man minus the velocity of boy. Velocity of the man with respect to ground is minus 2I minus velocity of boy is 16I. So the answer would be minus 18I. These are the answers. Once you get question number 1, I think you should be able to solve question number 2 and 3. Yes or no? These are pretty simple ones. Once you understand this part, which part? Once you write all these velocities as vector, the next part is very simple. You have to subtract the two vectors, get the answer and stay happy. I'll give you 1 minute to note this down and then we'll move on to the next category of problems. What I have done or what normally everyone does is we do this chapter under different categories, different types of problem. Right now we are doing just general problems. Now we'll go to a specific category and the first category of problem. Anyone has done this? So the first category of problem that we are going to encounter, if you have done this, shall we move? So the next category or the first category of the problem that we are going to encounter are rain and man problems. What is this rain and man problem? Well, they are pretty damn simple. What you have normally is you have a man with an umbrella and he is walking and obviously it begins to rain. So then the problem begins. At what there are two things that are asked in this: at what angle he should hold his umbrella, first thing, and then what is the velocity of rain with respect to man. So this is the most general case of formula where you see this man, don't have to draw the exact man is walking and in most of the cases rain is falling vertically downwards. Whenever we see VR Oops, wrong color. Whenever we see VR or we see VM, these are velocities of man and rain with respect to ground. So man is walking like this. In this case, we have just taken rain is falling like this. Now, what they ask here is number one, what is the velocity of rain with respect to man? So we can easily find out that thing. Velocity of rain with respect to man would be velocity of rain minus velocity of man. Yes or no? Do we understand this? In this case, it is vertically downwards and it is horizontal, so it will be simple VR minus VMJ. Okay. The second thing that they're going to ask is what angle it makes with the horizontal. Uh, Here, this is the vector notation. If they ask you to find out the magnitude of this velocity, you can find it out as VR square plus VM square in this particular case, where it is falling vertically downward. It is, if it is not vertically downwards, then the formula changes because it is between two vectors. We have discussed this in the previous class. Yes or no? The second thing that they are going to ask is, he is holding this umbrella. Obviously, he wants not to get wet. So at what angle should he hold his umbrella? Now, to understand at what angles what he should hold his umbrella, you have to see what is the direction of rain with respect to man. And normally that angle is found with the vertical. With the vertical axis, we find out that angle. It is with the vertical axis that we find out the angle. And if it is falling vertically downward, it becomes velocity of man divided by velocity of rain. How do we understand this? If you have a look at this diagram, you will be able to understand how I have found out this angle. See, remember, it's an addition of two vectors. Velocity of rain is added to negative of velocity of man. I told you in the last class. Velocity of rain, as you can see, is vertically downwards in this case. Everyone sees this, yes or no? Man is moving forward, so negative of that will be moving backwards. That is why it is drawn backwards. So the relative velocity of rain with respect to man actually goes in this direction. It makes an angle theta. That is the angle theta that he must hold his umbrella to save himself from getting wet. So that angle theta can be calculated from Vm by Vr if it is a simple case of rain falling vertically downwards. If it is not falling vertically downwards, then what will we do? Let us first solve this problem. Let us first solve one problem and then we can see what happens next. I'll give you 2 minutes to solve this, to write this. Anyone has noted this down? Shall we move ahead? Okay, then we move ahead with this sample problem, a simple one. This is just taken from your module. If you have that module, it is a simple one. So get me the answer straight away. Rain is falling vertically. Obviously, rain does not go from top to bottom. It always comes from bottom. Rain does not go from bottom to top. It always comes from top to bottom. So rain is falling vertically down. with a speed of 10 meter per second. A man is moving with a velocity of 6 meter per second. Find the angle at which the man should hold his umbrella to avoid getting wet. I'll give you 1 minute to solve this question and get me the answer.
Sir, 3/5, sir.
Tan inverse 3/5. That is correct. Anyone got it? So it is very simple. I even don't have to draw the diagram, but still I will do this. This is my man. He is walking with a velocity of 6 meter per second. Rain is falling vertically downwards with a velocity of 10 meter per second. It is as simple as it gets. First of all, I can find out the velocity of rain with respect to man. So it will be 10J minus 6I. Yes or no? Velocity of rain minus velocity of man. 10J minus 6I. I can write it as minus 6I plus 10J. This is better to write it. Now I have to find the angle it makes with the vertical, tan theta with the vertical. Remember, whenever you are finding the angle with the vertical, you always divide x by y. Y is the vertical. If you want to find out the angle with the vertical, we divide x by y. If you want to find the angle with the horizontal, we divide x by y by x. The value of x here, we take the positive value 6 by 10. Tan theta is 3/5. That is the answer. Theta is tan inverse 3/5. Do we understand this, everyone? Okay, this is pretty simple. As you can see, most of the question in this cases are simple, but let me give you another one. Everyone got this? Shall we move ahead? Okay, now let me change something here. Rain is falling at an angle of 37° with vertical with a velocity 5 meter per second. A man is walking with a velocity 3 meters per second. You have to find out number one, find the velocity of man. Oh, sorry, not man. Find the velocity of rain with respect to man. Number two, at what angle he should hold his umbrella to avoid getting wet. At what angle he should hold his umbrella. So I'll give you 2 minutes. Solve this. No diagram is normally given in such cases. Without a diagram, the question passes on to you. You have 2 minutes to solve it. Anyone got any answer? Shall I do it? Okay. So first of all, you can draw a simple diagram. This is my man.
3/4.
Okay, let us see. This is the man. He's walking straight with a velocity of 3 meter per second. Now, look at the rain. This is the vertical. Rain is not falling vertically downwards. Rain is falling like this at an angle of 37 degrees. The velocity is 5 meter per second. So what I got to do is I got to resolve it into two components. This angle is 37 degrees. Do we see this? Yes or no? So this component becomes 5 cos 37. 5 cos 37 is 5 into 4/5. It is 4. Yes or no? And this component here, it becomes, let me take this out. This component, this angle is 37. So this angle, the vertical side becomes 5 cos 37. This becomes 5 sin 37. Sin 37 is 3/5. So this becomes 3 meter per second. So if I now write the velocity of rain in the vector form, it will be minus 3i minus 4j. Do we understand this? Yes or no? Velocity of man is plus 3i. Velocity of rain with respect to man. Velocity of rain minus velocity of man. So if I do it, I will get minus 6i minus 4j. Yes or no? Do we understand this? I can find out the magnitude of this velocity. That was the first answer. So it will be under root of 6 square plus 4 square. To find out the angle that he has to hold his umbrella, tan theta, you have to find out, remember with the vertical, you have to divide x by y. X here is 4, y here is 6. So the answer is tan theta will be 2/3. Do we understand this? Anyone has any doubts, please ask. Try to understand what you were thinking. Try to understand what you were trying and see what mistake or what you were thinking differently. Anyone understood this? Anyone got this answer?
Sir,
Yes, beta.
I cos 37 degrees is equal to 4. How we get, sir?
The value of cos 47, you must remember, is 3/5. 4/5. And the value of sine 37 is 3/5. Remember that sine of 37 degrees is 3/5 and cos of 37 degrees is 4/5. Will you remember this now? I've said that many times, I guess. Anyways, everyone understood this? Okay. I'll give you 1 minute to note this down. Shall we move ahead? Okay, let me see if you can do this problem.
Sir,
Yes, beta. Yes. Any doubt?
sir, tan theta x by y 6/4 no, sir.
I've written. Oh, I've written it 4/6. Sorry. I've written it 4/6. Sorry. It should be 6/5. 6/4. I've written it wrongly. Sorry. Yes, correct. It is 6/4, 3/2. Correct. Shall we move ahead now? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Let's see if you can do this one. Now, read the language of the problem and see what is different here. A man moving with 5 meters per second observes rain falling vertically with the rate of 10 meters per second. Find the speed and the direction of the rain with respect to ground. Let's see who can do this. Yes, anyone could do this. Shall I do it?
So velocity of rain with respect to ground is 15 meter per second, sir.
Is how much?
15 meter per second.
1,515. How did you get 1,515? 5 plus 10, 15. Anyone with any other answer? Rain is vertical. Man is walking not vertically. Okay. Now there are two ways in which you can do this. First of all, you must understand what is the meaning of the first line. A man moving with 5 meters per second. So this is definitely velocity of man with respect to ground. So let me take ground out. This is velocity of man. That is 5 meters per second. Observes rain falling vertically at the rate of 10 meters per second. So when he is moving with 5 meters per second, when he is moving with 5 meters per second, he observes that the rain is falling vertically. That means this has to be the velocity of rain with respect to man. He is moving 5 meters per second like this, and he is observing rain falling 10 meters per second like this. Do we understand this? Yes or no? That's it. As soon as you understand this, The question is over. You have to find the speed of the rain and the direction of rain. So basically what we are supposed to find out is the velocity of rain with respect to ground. That is what you need to find out. Now there are two ways to do this. Let me tell you the first way. I am not going to write anything. I am not going to draw anything. Now remember what we had known. Velocity of rain with respect to man is velocity of rain minus velocity of rain minus velocity of man. Yes or no? Yes or no? That means I can write this equation in a different way. Velocity of rain will be velocity of rain with respect to man plus the velocity of man. Yes or no? Do we understand this? That's it. That's all the question. Velocity of rain with respect to man. Look very closely. Open your eyes. Universe is great. It is 10 downwards. So I write it minus 10j. Velocity of man with respect to ground is given here. Plus 5i. So it basically becomes 5i minus 10j. That is the velocity of rain with respect to ground. If I want to find out the magnitude, I can find out the magnitude like this. 5 square plus 10 square ka root. Yes or no? So that will be, I think, 5 root 5. And then I can find the angle it is falling, angle with the vertical, x divided by y, 5 divided by 10. I hope I have done this correctly now. That is half. That is way number 1 of doing this. Do we understand this? Yes or no? The only difference between this case and the previous case was, in the previous case, velocity of rain and man were given with respect to ground, and we had to find out velocity of rain with respect to man. Here, velocity of man was given and velocity of rain was given with respect to man. From there, we had to calculate the velocity of man. Sorry, velocity of rain. Do we understand this? This is way number 1. Way number 2, it's same thing, but drawn in a vector form or diagram form. So what will I do? I will draw the vector of this one. This is velocity of rain with respect to man. It is 10 meter per second downwards. Then what will I do? I will add the velocity of rain, velocity of man with respect to ground, which is 5 meter per second. If I add these two vectors, I will get the resultant vector. So basically what I have done here, my dear friends, I have written this equation not as an equation, but drawn it as a diagram. Velocity of rain with respect to man plus velocity of man will give me this vector, which is triangle law of vector velocity of rain with respect to ground. Yes or no? No, yes. This is a right angle triangle, so you can simply find out the length of this side, 10 square plus 5 square. And you can easily find out this angle, tan theta. Tan theta will be 5 by 10. So you get both the answers by drawing a simple diagram. Do we understand this? This is method number 2. Both are same. In one, I have done it by writing. In the other, I have done it by drawing it. You understand this, yes or no? Okay. I think that is enough that to do. I don't think that we need anything else. Shall we move ahead to the next category of questions? And the next category of questions are the famous river boat or river man problem. So we'll move on to the river man or river boat problems. Everyone must have read about this relative the motion of a river and a boat. So that is the next category of problems that we are going to deal with. River boat or river man problem. So there will be a river, there will be a man, and the man or the boat will try to do something. Now again, I can divide this problem into two different classes. The first class is very simple. It is upstream downstream problem. And these are the simplest problem. Upstream downstream problems. Now upstream downstream problems are basically relative motion in 1D. So we'll go back to relative motion in 1D. Now what is going to happen here is there will be a river. Obviously it's a river boat problem or river man problem. So there has to be a river. So there will be a river. Let us say like this. There would be a river. Obviously the river would be flowing. So river, let us take flowing in this direction. River is flowing in this direction. Normally the velocity of river is given u. Remember this u is the velocity. Remember this u is the velocity of river with respect to ground or earth. We take it as u. Now the river flows like this. If I flow along the same direction, if the man flows like this along the green belt, that is known as the downstream. He is moving downstream. Do we understand this? He moves downstream. And normally this velocity with which he moves downstream is given as v. So v will be the velocity of man or boat. Remember, it will be always given with respect to water or with respect to river, because man is going to swim or boat is going to sail in the river only. So if it goes along the same flow, that is known as downstream. Then what is upstream, my dear friends? If he moves like this, that means he is moving upstream. And then his velocity v would be in this direction. In both the cases, the velocity of the man or the boat will be given with respect to the river. Do we understand this? Now, the question will have very simple things. Velocity of the river would be given, velocity of the man with respect to river is given, and then it would be given that he moves some distance downstream, he moves some distance upstream. What is the time taken? Now remember, when he is moving downstream, then what happens? When he is moving downstream, his velocity of man with respect to ground, so let me not write ground, because he is going to cover distance with respect to ground, will always be equal to velocity of man with respect to river plus velocity of river with respect to ground. In this cases, both of them will be in the same direction. Yes or no? So they will get added up. So it will become v plus u. If I just write in form of vectors, it will be scalars, it will become v plus u. So basically he is going to travel faster because he is moving with the flow of the river. Do we understand this? But what happens when he moves upstream, my dear friends? When he moves upstream, if I again find the velocity of, why I'm writing R? If you again find the velocity of man with respect to ground, the formula is still same velocity of R. Velocity of man with respect to river plus the velocity of river. But in this case, river is flowing like this and man is flowing like this. Yes or no? So instead of they getting added, they will get subtracted. So in this case, it will become V minus U. Do we understand this? He will be flowing slower with respect to the ground because river is flowing like this and I am moving opposite to the river. So that is what you need to remember, that when he is moving downstream, his velocity with respect to ground becomes V plus U. When he is moving upstream, his velocity with respect to ground becomes V minus U, and then we can solve any question based on this concept. These type of problems are known as upstream, downstream problems. Do we understand this? I'll give you 2 minutes to note this down, then I shall present the problem. Let me know once you're done.
Sir.
Okay, then here comes a problem on your screens now. I forgotten the number, so I'll call it problem number 1. Upstream, downstream. A swimmer capable of swimming with a velocity v relative to water jumps in a river. Why to jump? Don't jump in a river. It's very dangerous to swim in a river. Just for the sake of problem, this swimmer is doing this. You don't have to do this in real life. A swimmer capable of swimming with a velocity v relative to water jumps in a flowing river having velocity u. The man swims a distance d. So what we need to note down is the velocity of swimmer is v, river is flowing with velocity u. He moves a distance d downstream and returns back to the original position. Find out the time taken in complete motion. So first he is going downstream, distance d, then he comes back, obviously upstream. What is the total time taken? And your time starts now. Yes, my dear friends, do we have any answer for this? Upstream, downstream problem. No one has any answer? Shall I help you out? You want more time? Okay. I'll give you 1 more minute. So, anyone? How do you find the time? First, let us take the case of downstream. The velocity of man with respect to ground becomes v plus u. Yes or no? How much time will it take? He has to move a distance d. How much time will it take to move the distance d downstream? The time would be simply equal to d upon v plus u. Yes or no? Well, so far so good. What next? Upstream next. When he moves upstream, the velocity of man with respect to ground now becomes v minus u. How much time will it take to move a distance d upstream? D upon v minus u. Let me call this as tu upstream. Let me call this as td downstream. You know both the times. What will be the total time? T upstream plus T downstream. And that is the answer, my dear friends. D upon V plus U plus D upon V minus U. I guess you can take the LCMs and give me the final answer. What is the final answer you are getting by taking LCM and HCF and all those things? Huh? No one got this answer? No one got it? Anyone who got this answer, please raise your hand. No one. It was not a very difficult problem. I must tell you, the NEET wala students, they are way ahead of you. They have already done circular motion also. They had done this problem on their own.
Sir,
Yes, beta. Yes, I think I could not get you, but I think you were saying 2dv upon v square minus u square. That is the answer for time taken to go down, then time taken to come up, the summation of these two times. So this brings us to an end of today's class. In today's class, we have taken the upstream downstream problem, but that was river boat or river man problem in one dimension. He was moving along the river flow. Now what will he do? He will try to cross the river. So that will be river crossing problems. We will be doing these river crossing problems in the next class. I hope you have understood this. If you have any doubts, you can ask me. Else we'll wrap it up. And I hope everyone is making notes. Yes or no? Okay. I would ask you to make short notes as well. So you make one copy for your main notes and your questions and answers, and then you make a short notes copy. In that short notes copy, you write all the important points, all the important formulae at one place. What is going to happen is with time, your classwork copies are going to get more and more. because it will have questions, it will have everything. Just make one notebook which is for short notes, write all the formulae, write all the important points in that note. That will help you in revising things faster, because when you see 10 notebooks, it will become very tough for you to revise it. But when you see only one notebook and you can do the entire course in one notebook, just write the important formulae, important concepts. One chapter will only take 4 pages. Even if there are 40 chapters, it will only take 160 pages for your entire 2 years. I'm talking. Make a short notes copy and start writing notes now. Okay, so do that. Complete the notes up till here and then make the notes. Okay, take care. Bye bye.
Thank you, sir.